Hi everyone. Today we're just going to do a quick radical review. I'm going to show you kind of two different ways to simplify radicals and then some rules about radicals that we need to follow. And this is going to come up a lot in chapter 8. First thing that you absolutely need to recognize is our list of perfect squares. Often I'll start this list from the right, and so you should probably recognize through, I don't know, say 15. And on the left-hand side, I'm going to write down what 1 times 1 is, and 2 times 2, and so on. And you want to recognize all these ones on the left. Whoops, sorry, that's a 36. You want to recognize all these ones on the left so that when you see them, you know that you have a perfect square and you can stop. All right, so these are all the ones you should recognize. And then everything else past this, we're going to break down so that we can kind of approach these problems two different ways. All right, so method number 1 here for number 1, not really my preferred method, but I like to show it to you. We're going to do all of our factors of 72. You want to be nice and organized in your list so that you make sure you get them all. I always start with 1 times the number and then go systematically in order. So it's 2 times 36. 7 plus 2 is 9, so 3 goes in. 3 goes in. Let's see, 24 times. 4 goes into 72, 18 times. 5 does not. 6 does because 3 and 2 both do. So 6 goes in 12 times. 7 doesn't. 8 doesn't. 9 doesn't. 10 doesn't, 11 doesn't, and then once your loop back up and here's 12, you know that you've got your complete list. Now, when you look at your list, you are looking for a pair that has the biggest perfect square. So 72 was not on my list from before, but 36 was, which brings us to our first rule about square roots or any roots, is that you can break them up with multiplication and division. And so instead of writing the square root of 72, I am going to write the square root of 2 times the square root of 36. And then, of course, the square root of 36, we know the answer to that is 6. The standard is to write that number out in front, and then I almost always close my radical so that I don't mistake what goes underneath. So that's kind of method number 1. The problem with this one is if I give you a really huge number, you might have a really long list. So instead, let me show you method number 2, which I like the best. The hidden little number inside here, this is called an index, is a 2, right? We call a square root. And so that's going to be important in a moment. All right, so what I'm going to do is the prime factorization. That is unique. That means no matter how you start breaking up, you are going to get the same answer as your neighbor. I'm going to start with 2 times 36, and then anytime you get a prime number, you're going to circle it. 36, well, that's 2 times 18. 18, that's 2 times 9, and 9 is 3 times 3. And now I'm going to rewrite my square root as the square root of 2 times 2 times 2 times 3 times 3. Because the little index was a 2, what that's telling us is we're looking for pairs of numbers. So I'm going to find a pair of 2s. I'm going to find a pair of 3s. And then I have a 2 here that doesn't have a pair. The square root of 2 times 2 will squaring, right? 2 times 2 is 2 squared, and square rooting undo each other. And so the square root of this, of this first one is just 2. The square root of this one is just a 3. And then what's left underneath is a lone 2. And so what's my answer? My answer for this one is 6 root 2. Notice that we got the same answer for both of these questions, but we did them in different ways. The reason that I like this prime factorization method is because now, if I asked you instead the cube root of 72, I've done all the work. The cube root of 2 times 2 times 2 times 3 times 3. But a cube root, whoops, I was trying to highlight that. A cube root means you're looking for 3 of a kind. So I have 3 2's. I have 2 loners that don't have a third. So I pull out those 3 2's and I'm left with a 9 underneath. And so that's kind of why I like this method, is because it then applies to any radical that you have. All right, I'm going to pause, and then I want you to try 3, 4, 5, 6. I'm going to do those out, and then you can check your answer.